Good morning, good afternoon, good evening. This is Professor Sistrunk, and I'm reaching out to the student body. Okay, students, we are in the thick of things. You have all of your particular portals. You are working in on these assignments. I see you in there. And what I want to do right now is just basically show you how I do my labs and how I expect you to give the labs to me. Now we already talked about downloading the content file and making sure you turn that content file into a PDF, not a PDF, turn that content file into a Word doc and then upload it into D2L when you complete all of the assignment, which is great. You get it. I am going to walk through this particular assignment, and in the process I'm going to explain things in this assignment that is critically important. So if you see me looking at the other screen, yes, I have my notes over here, and I like to talk to you from my notes instead of just throwing things out there. So I'm gonna pull up my notes here, and I am going to talk about this particular lab. But before I go into the lab, there's one thing I want you to get an understanding. This course is a process of courses. I want you to get skilled up to where you can go into engineering, be a network engineer, a system engineer, whichever engineer you want to go into. So let's go into the Cisco ecosystem. When you're inside of Cisco, you're going to see that it's a lot of classes that Cisco has to offer. The primary ones that we focus on are like this one here, Cyber Ops. As you can see, you got Cyber Ops Associate. That gives you a certification 200-201. But you can go to a must advanced certification, which is Cyber Ops Professional, which is 350-201. And then you got Cyber Ops Professional again, which is 300-215. And then you got Cyber Ops Professional, which is another CCNP, which is 300-220. Now, what's the difference between them? Well, one is understanding Cisco Cyber Ops Operation Fundamentals. That's what you're doing right now. You're getting to the point where you're going to understand this. Now, I know most of you have been through multiple security certifications, but I'm going to tell you something. Knowing the Cisco system puts you way ahead of a lot of the people out there. Cisco is king in the industry. When it comes to networking, when it comes to security, these are the devices you will be working on. The routers, the switches, the firewalls. Cisco is in there. Also, we got performing cyber ops using Cisco security technologies. That means you're going to utilize all the different technologies that Cisco have to secure organizations. We also have right here conducting forensic analysis. I know we have classes on forensic analysis, but in the Cisco world, the very devices you'll be working on will be from Cisco. Now, of course, there's a lot of vendors out there, but I might be pumping Cisco up a little bit more, but you get it. Then you got conducting threat hunting and defending user Cisco technology. So there you go. I know we got separate classes that deal with this, but this is actually on the different devices or separate certifications dealing with cyber ops. Associate level into being an engineer. So take a look at this. Now, you know we have other classes in here too that we teach. We teach also the enterprise level classes. I am developing a program to bring in CCNP Enterprise. I hope some of you guys will come back and take these classes because I'm putting that together. And if you're interested, please send me some emails so I can go to my dean and say, hey, we got people who are interested in this. But this is advanced level. This is the engineering level. Also, we have in here, so I talked about CCNP on the engineering level, but we have down here some certs that I'm going to be pushing heavy on that has to do with, getting you started. See, the entry level for us was certification called networking. But now we're changing the platform, and some of you are experiencing the platform change. We got Cisco Certified Support Technician, CCST, that's IT support, networking, and also cybersecurity. So what we're about to start doing is teaching these classes, moving to the associate level classes, moving to the engineering or professional level classes. That's my goal. That's how I'm trying to structure this. You start at the entry level classes, you go to the associate level classes, then you go to the professional level classes. And with those certs, you should be able to go out and say, hey, I'm an engineer. I know what I'm doing. Let me get the experience now. So I hope this was helpful. I'm gonna put the link on my YouTube page so you can pull this link off. But take a look at these classes. And like I said, if you're interested in these classes, please shoot me an email saying, hey, Professor, I'm interested. Because this gives me a chance to go to the deans and the powers to be and say, yes, I can go ahead and start creating this because people are interested in it. So now that we talked about that, to net labs and do a lab. Okay, as you can see, this is one of the basic labs right here, your starting lab. 3.0.3. Now, I'm doing this lab because I want to make sure it's things in here that you know you should be doing before you start turning your work in. And of course, it's a Saturday, so you may say, I already did it, Professor. Go back and give me what I need, because it's important that I'm able to review your work really good. For those of you who took my Linux classes, you're going to see a lot of Linux in here. So that's why it's important to be a real good cybersecurity operator or cyber ops operator. You have to know Linux. Now, I know some people say, well, I'm in the cybersecurity world and I don't know Linux. Yeah, but you on a user basis. We're trying to get people who will really go into it and get so deep that they want to be professionals or go into the engineering status. Okay, like I said, I made it into a Word doc like I'm teaching you how to do. Make it into a Word. As you can see, this is Microsoft Word here. If I pull it down, you can see this is Microsoft Word. So you're going to take the PDF, you're going to transfer it into a Microsoft Word doc so you can answer these questions, okay? The first thing you should be asking yourself, and once again, if you see me looking over here, you know what I'm looking at. I'm looking at the steps. The first thing you should be asking yourself is, what are what we call identifying running processes? You should be able to explain this to any IT manager because it's pertinent that you understand what are processes. Now, of course, processors are applications that work in the background of computing. Just imagine a computer as an office, a computer as office. It's a lot of things going on inside of that computer. There are processes that get the computer started. The moment you push the power button, processors kick in. There are processes that help launch applications, whether it's a web browser or whatever particular applications. These processes are critically important. But one of the things that's important about these processors is that you want to make sure they're the right processors. Because if they're the wrong processor, they can be using up a lot of processing speed, they can be using up a lot of memory, they can be using up a lot of hard drive speed. These things can literally slow your system down. And there can be some malice intent behind them because they could have been a hacker who came in and took over your machine, and now they draining your machine to use it as a drone to attack other machines, or they using your machine to try to attack your organization and get information outside of your organization. So you get the idea behind processors. One of the key things I want to make sure you understand is that not all processors are good for the system. You have to be able to know the problems that these processors can cause for any particular system. So that's why it's important that you study this lab. Start asking yourself, why am I studying the labs that I'm studying? What is the reason? Because when you sitting back as a network administrator, a system administrator, A cyber ops administrator, when you're sitting back watching your systems, you have to know what should be happening and what shouldn't be happening. And when things start spiking in your systems, because you're going to be looking at all of the computers, when things start spiking, you should be able to step in immediately and say, that shouldn't be happening. Or why is that processor doing that? Why is this processor trying to open up applications that it shouldn't be? Or why is this processor trying to get on the internet? Your job will be as a cyber security analyst to stop that. And that's what you will be. Let me pull up something so you can get the real deal on what cybersecurity analyst is about. As you can see right here, this course here teaches you this, how to monitor, and I might have to bring this up a little. Okay, there we go. How to monitor, detect, analyze, and respond to cyber crime. So your job is to monitor, detect, and analyze any problems that you will have in your organization. That's what organizations are hiring you for. You know, you may be working inside of a SOC center, but the key to walk away, am I monitoring systems? Am I detecting issues on the systems? Am I analyzing the systems? And do I have a rapid response when there's a problem? This is critical for you to pay attention to. So don't just blow through the labs and say, oh, I did the lab, professor, here you go. If I ask you a question about a lab, you should be able to respond. So if I walk up to you and say, what do they mean when they say identifying running processes? You should automatically know from our conversation that these are processes that are behind, that are in the system, that are functioning to keep the system healthy. But we got bad people that can take over these processes and drain the system. Okay, let's get to the lab now. I know you're saying, Professor, let's do the lab. So let's do the lab. Okay, so let me go to the little notes. Now, one of the things that's important, you always want to check your status. My status is good. I talked long enough for my status to be good. You know the topology. This is your topology right here. And you got a system here that you can work with. Now, the system is ready to go, okay? So the first thing it wants you to do is find the particular processes. Now, the path we are going to use is different than other way other people can use. Other people got other ways to go to processors. Now, one of the things I was trying to tell you earlier, and you know when I keep looking this way, I'm checking my notes, is that you got ways to check your processor using Windows. You can go to Windows Task Manager and test your processors. You got ways of testing your process in the Linux world. I'm gonna see if somebody know. Put in the notes, what command can you use to check processors in the Linux world? So put that in the notes on my YouTube page so I'll see. I'm gonna make that a question to see. And even with Mac computers, you can also check processes. But I'm gonna see if I can do this real quick. I'm gonna go Control Shift Escape and see what'll pop up, and nothing popped up. Yeah, there it is right there. It did pop up. So this is another way from the way you learning processor. If you just hold down the Control key, the Shift, and the Escape button at the same time, it will show you all the running processors. As you can see right here, these are all the running processors in the background. But this lab is going to show you another way to do it. But just know, holding down the Control key, the Escape key, and the Shift key, Control Shift Escape key, that will bring up all the processes that's working in the background. And you want to be able to check them. Now, if you work for an organization, of course, working for that organization, you automatically know what applications are on the system. Now, you see what I just did? Processors are nothing but programs, which are applications that sit on your system that you have to monitor and make sure no one is trying to damage the system. That is. But this is another way. I don't want you to get stuck on one particular way to check for processes. If you can, put on my YouTube page in the notes what other ways you can check processes. I just gave you 2 ways. I told you the Windows way using the keyboard, and they gonna show you this way in going through this lab. But just know why we go after processors, why we focus on processors, why we monitor processors. This can be really dangerous for an organization when people hack the system. Hack the system. Okay, let's move on. Let's get through this lab. It's a short lab, so it's not going to take that long. Okay, so it wants you to actually double click on here. Okay, now when you double click, guess what you're going to do? You're going to go do what? Take a screenshot. Blah, blah. There it is. I don't know why I did that, people. I'm having too much fun. So I got that. The next thing it wants you to do is double click on here. Once you double click on it, showing your professor you doing the work, you're going to come here and you're going to take a screenshot. There it is. I can see it. Submit. Okay. Then the next thing it wants you to do, I'm going to blow this up so you can see it full screen. The next thing it wants you to do, I like to do this, like put it in alphabetical order. If I do it going down Z to A, you'll see the file that I'm looking for is right here. Right here. Right there. So you see the file that I'm looking for right there. Now it wants you to open up that file. Okay. Once you open that file, there you go. You're looking at multiple processors that's happening in the background of your system that you want to make sure that you watch. Okay. So we went through them steps. Now I'm going to take a snapshot of that. You got up to 50 snapshots that you can take in one lab. So every lab gives you 50 snapshots. I should be able to walk through those snapshots and see that you're completing the work. But wait, you also have to complete the document in Word and upload the document in D2L. So I can take your document and look at your work, your screenshots, and make sure you're doing the work. If I don't have both of them, you didn't do the work. Let's just keep it real, okay? Now, of course, it asks you in here, once you did that, it's asking you a couple of questions that you're going to answer. I'm not answering the question for you. That's on you. But it also wants you to go in here and click on options. And when you click on options, say always on top, which you could have did it the other way I just showed you this way. But it wants you to also click on this here and open that up, and you're going to take information out of that. But before you take the information out of that and put it on the file, you're going to take a screenshot. There you go. I got that screenshot. So guys, you get the point. I need the document and I need to see you doing the work. I need to see both of them. Okay, so, and I think that's it. Oh, it also wants you to, I'm going to close this. I'm not going to tell you what information it wanted you to take from there. I think you can read. I know you can read. But it also wants you to open up a web browser. When you open a web browser, you see the processors acting. And that's what makes this whole thing critical for you. Because you'll be able to, as a cybersecurity specialist, look at the processors that's happening and be able to say, that should be open. But that process, I don't know what that is, and it shouldn't be open. I'm going to put a little dialogue inside of this email when I send it to you so you can read it and understand what processes do. I'm going to keep doing this all the way through because I want to educate you and make sure you understand what you're doing. With that being said, I'm going to close out on this section because I think that's the end of it anyway, and I don't want to make this too long. I want to say this is Professor Systrom, and I'll see you in the next video log. Bye-bye.